So I want you to think an answer. So the heading is basic properties of charge. So what are the basic properties of charge? The first one, I'll not reveal the name. We'll try to understand a concept and then give a name to it. Okay. So, nucleus, orbit, electron. Okay, accepted. Now, if I need to charge that material, I need to do something with an electron. So you all know that the charge of the electron is represented by the symbol E, and you know the value of it. It is 1.602 into, this is a value to be remembered, into 10 power minus 19. What is the unit used for it? You use a capital C, which is called as Coulomb, which is the name of a scientist. So 1.602 into 10 power minus 19 Coulomb. Am I right? And if you don't know, have this in your mind. No. And charge is represented by the symbol Q. Okay? Now, if I say a material is attaining some charge, it has a dependency on the charge of an electron. Am I right? So I'm trying to understand. I've not yet framed the equation. Look at the way I'm thinking about it. Charge on a material has something to do with the charge of an electron, accepted? Right? Now, if I lose an electron, what is the charge it is going to get? Positive or negative? Positive. If I gain an electron, it is going to get negative. Is there a scenario, or does it make sense when I tell you there is a loss of 1.5 electrons or 1.75 electrons, 3/4 of the electron is lost? Does it make sense, right? So what should happen? The material should either lose 1 electron or it should gain 1 electron, or it should lose 2 electrons and gain 2 electrons. There is no intermediate number between the 1 and 2. Right? So it can either, let's talk about lose itself. It can either lose 1 electron or 2 or 3 or 4. All these fall under the set of natural numbers. So can I say Q is equal to N into E? You can use capital N also. If you want to purely follow mathematics, you can use capital N, or small n is also accepted. Okay. Now what I am doing is, I am adding a prefix to it as plus or minus. So what is it trying to tell me? So when it is plus or minus, not plus and minus. If it is plus Ne, what is the meaning of it? It has lost electrons. If it is minus Ne, it has gained electrons. So if I look at this mathematical expression, right? Small n, I told you it is a natural number. To a natural number, if you add a plus or minus sign, it becomes an integer. So if I take this to be the mathematical condition, now I'll try to write a statement for it. Total charge on a material is, look at the way I'm converting, okay? I'm not memorizing or doing anything. I hope you understood the mathematical statement. Look at the way. The total charge on a material is, what is it? What is the next thing I'll be able to say? Is equal to, right? Is equal to whom? An integral multiple is equal to, and see, integral here doesn't mean the symbol integral. Integral means integer. It's an integer multiple of whom? Of E. E is what? E is the charge of an electron. So it's an integral multiple of charge of an electron. Some books represent it as the fundamental unit of charge, because electron defines it's the fundamental unit of any charge. Are you able to understand what I'm trying to say? So mathematically you write it as Q is equal to plus or minus N into E, and I told you I'm not going to reveal the name. No, now I'll tell you. This kind of a mathematical condition is what is called as quantization of charge. As the name suggests, it's very simple. Quantization comes from quantifying, means you're giving a number to it. Quantization of charge. Am I clear with this? This is the first property. So actually you're supposed to study in the reverse. Okay, you have to first write it as quantization of charge, then write the statement, then you'll write it. But it'll be like memorizing. I thought we'll use a logic and write it in the reverse. Right? Am I clear? Right, this is the first property. So let me know once you're done writing it. So I told basic properties of charge. So there are some more properties. Let's understand what they are. Shall I proceed? Yeah. So the second one, see, let's say I have, so from the quantization I understood that I can either lose integral value or gain integral value. You cannot have plus or minus always. It should either be plus or a minus. Suppose I have a system where there are two charges, right? Where there are two charges, and let me say that this material has a charge of plus 5e. So what is your understanding of this? It has lost 5 electrons. And here I am saying minus 2e. What is your understanding of this? It has gained 2 electrons. Now what I'll do is I'll take these two potatoes and put it in a box. I'll isolate it from the surroundings. Means only these two charges can interact. They cannot interact with the surrounding. Means if at all they lose or gain any charge among them, it can happen only among themselves. It cannot happen with the surrounding. Then this kind of a system is what is called as an isolated system. Make sense? Make sense? Right. Now, what I'm going to do is, see, you need to know this fact. Whenever you have two charged materials, you try to bring them in contact and move them away. There will always be a redistribution of charge taking place. Redistribution means transfer of charges that is going to take place. How it is going to get transferred, that we don't know. How much value will get transferred, that we don't know. That depends on many other factors. Now what I'm doing is, I'm taking these two charges in the isolated system. I am bringing them in contact. And moving them aside. Brought and taken away. So that what is happening? What will happen? After contact, what will happen? There will be, I want that word, redistribution of charge. Means the charges get transferred from one to another. If that is the case, let's say that the first material here has now become plus 3e. Now, what would be the charge on the second is what my question is. What did I tell you in the beginning? Since they are isolated, if any transfer of charge takes place, it can take place only among themselves. It cannot take place anything outside. Right? Now, I'll be able to answer this question if I think of a small logic where I'm trying to understand what is the total charge present in the system. So, what is the total charge present? Is it not 7e? 5 plus 2. It should be 7e, no? Sure. Plus 3, correct? Correct. Why? You are adding them. What kind of addition are you doing? You are not adding them numerically. You are adding them algebraically. Because sign is important, so this is wrong. Answer will be plus 3e. That is the charge of this isolated system, right? Then what should be the charge that is present on this isolated system? It should be plus 3e only. Meaning plus 3e from here should exactly be equal to plus 3e from here plus this x. I don't know what is the nature of charge. That mathematics will take care. So what am I getting here? Here I am getting answer to be 0. I'm not multiplying, I'm adding them. It's a 0. Right? So what is the meaning of this? Here the charge is 0 means it has become neutral. Am I clear with this? So here you used two properties. One is when you added the charges algebraically, you used a property called as additive nature of charge. Right? And the second thing is, when you told the total charge here and the total charge here is the same, you used another property called as conservation of charge. Are you able to understand? So the next one we can write it as, see, these two are interconnected. Am I clear? So additive nature of charge, can you give me a statement for it? Can you give me a statement for it? You already told what you're supposed to do. I gave you numbers. You added them. How did you add them? Algebraically. So with that, with those words, frame a statement, no? Okay. So here when you talk about additive nature, no, we need not be an isolated system, because additive nature is applicable even for an outside system. Here we try to understand conservation. So basically, if you have a system, and if you have a system of multiple positive and negative charges, whenever you want to find the total charge of that particular system, what you do is, you add them algebraically. That's it. Okay? Total charge present in a system is an, underline this word, algebraic sum of whom? Of the individual charges present in the system. Are you able to understand? So this one we'll use it multiple times in this chapter. So have this in your mind. Total charge present in the system is an algebraic sum of the individual charges present in the system. Divya, are you able to understand?
Yes, sir.
Yeah. So what is the next one I told you? Conservation of charge. You give me a statement for it. Now for here you will use conservation of charges. The total charge present in what kind of a system? Isolated system is always a constant. Total charge, when I say total charge, additive nature is covered. Total charge present in, help me finish it, present in an isolated system is always a constant. See, some books refer to it like this also. Charge can neither be created nor be destroyed, but it can be transferred from one particle to another, but that's not the way we define it here. So we say that total charge present in an isolated system is always a constant because we have an application perspective of this. So what I'm trying to tell you is, wherever you see an isolated system, if you see that word itself, the first thing that should come to your mind is charges are conserved in that system. I hope I'm clear, right? Okay. Yes. Shall I proceed? Yeah. I told you, when I explained about charge, I told you two things. What are they? One is we need to understand how you can create the charge. Second is what are the properties exhibited by them. We saw the properties. Now the question is,